Hello everyone and welcome to We Meet at Digital Days. My name is Marie-Therese Kohl and I will moderate this presentation. We are very pleased that you took the time to participate in our virtual conference. The topic of this presentation is Passive Components Introduction of New Products. Our speaker is Thomas Brander. He will hold the presentation and will answer your questions. Before we start, I would like to point out one thing. You will be muted during the presentation. This means that you cannot ask questions via microphone during the presentations. Nevertheless, you have the opportunity to ask questions during the presentation at any time via the chat function. You will find the chat function in the control panel. This presentation will be about 15 minutes long. The chat questions will be answered in a Q&A session following the webinar. There are 5 minutes in addition scheduled for this. If we are unable to answer all your questions within this time, we will answer them via email afterwards. If you still have any other questions left, mail us at exhibitions@we-online.com. We will try to answer all questions promptly. At the end of the webinar, you will be asked to participate in a feedback survey. We would be pleased if you take the time to fill out the survey and help us to improve our event. You will receive the link to the presentation in the next few days. The recording will be available at our website shortly. But now I will hand over to our speaker Thomas, and I wish you an exciting presentation.
So thank you, Marie. I want to show you today the passive components, what we have on new products. My name is Thomas Brander and I'm head of a part of the passive components of the product management. And for all the products which are for EMC and inductive solutions. And I want to start right now and show the new products. So first of all, I want to mention that we have our small tiny signal transformer, the WE-STST. We have now also available for power over Ethernet, so which makes it possible to handle currents up to 600 milliamps. So a little bit more. So our STST ports are very small for a transformer, for a signal transformer, and they can be used in LAN equipment for 10 and 100 base T, but also for 1 gigabit base T and also for 10 G base T. The ones with, for the low speeds have a inductance of 350 microhenries, which is also required from IEEE. We have isolation voltage for 1.5 kV AC and or 2.25 kV DC. For the new PoE parts, we have current capabilities up to 600 milliamps. And of course, all our models are available as parameters, LT-SPICE models, and so on. Applications, like I said, it's Ethernet, and you can use it for 10, 100, 1000 base T and up to 10 gigabit base T. And what's the new is really the power over Ethernet versions. Another application of it is single pair Ethernet. So you maybe know our landing page, what we have for single pair Ethernet. Does not work, the link. Where you can get more information. There was also a presentation, right in front before me, which is also working for the single pair Ethernet. In single pair Ethernet, there's also something similar like power over Ethernet. It's called power over data line, and also therefore our transformers can be used. We are also here in a very close collaboration with the leading IC houses to define reference designs. The next product I want to mention, need to go down a little bit, is our auxiliary gate drive transformers. So it's transformers which can be used in gate drives for silicon carbide MOSFETs and for IGBTs. I also will here switch over to the presentation as there is more information inside. So they are optimized for silicon carbide gate drives with a very low interwinding capacitance. This capacitance is down to 6.8 picofarad, which can then handle a very high CMTI, common mode transient immunity, of more than 100 kilovolt per microsecond. They are all applicable for the safety standard 62368-1 or IEC 61558-2-16 for a basic insulation for working voltages of 560 volts AC or 800 volts DC. They can handle up to 6 watt power, and we have unipolar and bipolar outputs. Most of the silicon carbide gates need a bipolar driven gate voltage. Therefore, we have the both with the bipolar. Some are also available with unipolar gate voltage. They are very compact, what I will show you on the next slide. We have ASEQ 200 qualification and some reference designs already available. So they are built on a very small package, EP7. Most of the data here are already in. They have input voltage possibilities of 9 volt and 36 volts, and a very high efficiency. What's new on silicon carbide gate drives? Typically, a gate drive transformer is a signal transformer. In the case of silicon carbide, most of the IC gate drivers, they already bring the signal to the secondary side or to the output of the gate driver and to the gate. But they don't have the available power to drive the gate. So therefore, there's needed an auxiliary power supply, which gives the power or the output power to the input of the gate. And the second thing is most of them need a positive voltage to drive the gate and negative voltage to pull the gate down. And we have now these transformers which have a positive and a negative output. And we have online our reference design where you can, which you can just copy to build up your auxiliary gate drive power supply. It's based on a flyback topology, and you can find the reference design. I will send the link in the presentation, which you can, I think, download also from our homepage. The last product which I want to show, as a new product, I still have then some highlight products, is our shielding cabinets, which we have now in a seamless version. You can see it here. There's no cut inside the cage, which gives you a much better shielding possibility, as you have a really closed Faraday cage then. We have there more than 100 already available sizes, and can also make here some customized versions if the quantity is high enough. This is especially useful if in all the new higher frequency communication things like 5G, IoT, IO-Link, and GNS. As already told, we have here deep drawn top of the cage, and also here it's deep drawn, so we have no cuts inside our cage. The standard material is plated steel. We have a pick and place cap for the bottom side of the cage, and all of the cabinet, and it's fully closed to have the advanced properties. The advanced properties you see also in this measurements. So for the normal shielding cabinets, they have normally an effective shielding frequency range from 3 to 5 gigahertz. With the new seamless shielding cabinets, we can have effective shielding up to frequencies of more than 60 gigahertz. For harsh environments, we can also supply the cabinets in a different material, which is nickel silver material. I have to close this now. I also want to show you on the other side some of our focus products. The first one, what I want to show you is we have new antennas, and the benefit of these antennas is that they need a much smaller grounding space, grounding place, and a much smaller ground clearance. That's you can have it for if you have less space, so you can the antennas need much less space than the antennas which we had before. And we have them for a lot of frequencies and for a lot of applications like IoT devices, GSM 900, both Wi-Fi frequency ranges 2.4 gigahertz and 5.5 gigahertz, Bluetooth, GPS, Zigbee, LoRa, and LPD. So a lot of frequencies are available. Also, I want to mention here that we also offer a service that we make the antenna matching for you. So the design of the matching circuit, which you need on your PCB, because this is always depending on how the PCB is built up. Another highlight product is the Commode ceramic Commode filters, which we have also for higher frequencies here. I also will show you here the slide. So normally we have on the Commode filters sometime at some point that the differential mode filtering will start, or that the differential mode will start to also influence the signal. And especially if you have high frequency solutions, like there's a Wi-Fi next to it, and other radio signals, then it's important that you have a good Commode filtering of your circuit in this range, but you should not touch the signal in this frequency range. And with the new CCMF, the ceramic Commode, we can filter up to more than 10 gigahertz without influencing our signals. And the last one is we have a new current sense transformer, which is much smaller than what we had before. Before we had the EE5 current sense transformers. Now we have also the EE4.4 current sensors. Also, we improved the EE5 current sense transformers for higher currents. So with the small current sense transformers, the EE4.4, we can reach currents up to 7 amps, and for the new EE5 we will have up to 20 amps now. So thanks for listening to our new products, and I'm now open for your questions.
Thank you, Thomas, for your interesting presentation and also for showing our virtual exhibition booth. As you already mentioned, now we would like to turn our attention to your questions, and we will wait a little second until some questions have come in. You can enter your questions via the chat function in the webinar control panel. But Thomas, so let's turn to the first question. What are the differences of the new WE-AGDT gate drive transformers and classical gate drive transformers?
So the difference is what I already mentioned before. You only had a signal transformer. So the IC gave out the gate signal, and the transformer just transferred this signal to the other side of the transformer and made this isolation. For the silicon gate carbide gate drives, you need more power to drive the gate because there's more power needed at the high frequencies, and therefore typically the signal is done directly by isolation in the IC. In the gate drive ICs, they already have some isolation inside, but they cannot provide the power to the outside and to drive really the gate. And therefore, there's a the auxiliary power supply. So you don't need only a transformer, you need a whole power supply, which really drives the power on the input of the gate or on the output of the gate driver.
Okay, thanks. Another question, Thomas. Why is it important to have a low coupling capacitance for SiC gate drivers?
So I tried to show you maybe one additional slide, which I have at the end. Is it visible, this slide? No, it's the wrong one.
I think in a second.
So now it should be hopefully visible. So
Yes, it is.
The reason is for silicon carbide, we have very high dV divided by dt. So the voltage change is very fast, and which means it can be driving through the capacitor of the transformer and also of the gate driver down to my earth, which will generate a lot of common mode noise. And with this common mode noise, you will have different difficulties for the EMC. The other thing is vice versa. If there's a transient on the common modes, then this will be also transferred to the output, which is not what helpful for the output. And as you see, the voltage or the current which is driving from the primary to the secondary or vice versa is directly proportional to the capacitance of the driver, so of the transformer itself and also of the driver, which is there in parallel.
Okay, thanks, Thomas. I would say if there are any questions left, we will answer them via email afterwards. But for now, we are finished with this presentation. Thank you very much, Thomas, and thank you all for your attention. And I hope you enjoyed our presentation. The next presentation is Wireless Connectivity and Sensors, Introduction of New Products. This presentation will start at 11:30. See you there and enjoy our digital days. Goodbye.